Hello and welcome. In this video, we're going to be revising the trigonometry chapter or trigonometry exam questions. This is going to be a full one-stop video revision for trig for your Pure 2 exam. So before we start, I just want to show you these identities. Okay, it might seem a lot, but we're not gonna use all of them. I'm just gonna show you which ones that we need to focus on, and I believe that for this chapter the best way to revise is to solve as much ideas as possible. So this is what we're gonna do here. We're gonna cover as much as we can. Before that, I would like to tell you that I've created a mechanics, because the mechanics test is soon as well, a mechanics Udemy course. It's a full mechanics course. Everything is explained, past papers solved, topical solved, every single thing you need for mechanics. It's there, it's on Udemy, and stick around to the end of the video. I'm going to give you a gift as well as a preview of the course. It's in the link down in the description. Email me an email titled Udemy Mechanics course, and I'll see if I can send you a discount code. Actually email me and I'll send to everyone a discount code for the course. Anyways, let's start by solving this first question. This question says that it's given that 3 sine 2 theta equals cos theta, where theta is an angle such that theta is in between 0 degrees and 90 degrees, non-inclusive. So it's not 0 and it's not 90. Find the exact solution of sine theta. Okay, first of all, I can see that there is a huge thing over here, is that sine 2 theta here, and I find sine theta over here. This is a great indication or a great starting point that we need to focus on. Okay, so over here, when we have something like this, in order to solve, we need everything to be in terms of 2 theta or everything in terms of theta. So what we are going to do here is we are going to use an identity. I notice that we have a double angle identity here, sine of twice the angle. So let's see if we can look at the double angle identities, which are over here. So this double angle identity tells me that sine 2 theta is going to equal to 2 times sine theta times cos theta. Let's see how that will help me. So I'm going to change the sine 2 theta into 2 sine theta cos theta. So this is going to be 3 into 2 sine theta. It's no longer a double angle. Now it's sine theta, just like the other part. Now I can solve. So it's 2 sine theta cosine theta equals cosine theta. So now the question tells me what is the value of sine theta. What I can do is I can divide cos theta from both sides. This side is going to be 1. Equal to 3 times 2 is 6, so 6 sine theta. So sine theta is going to equal basically 1 over 6, and that is my answer over here. Questions are going to get progressively harder, so stick around. This is just a refresher, and then I will show you how to solve the harder questions. Okay, now the question says find the value of secant theta. Okay, what is secant? Secant theta is equal to 1 over cos theta. Right? So if I found cos theta, I can reverse it, and then I can find secant theta. So how can I find cosine theta? From the first part, I know that sine theta is 1 over 6. So if I do a little triangle, a little right angle triangle over here with, let me call this angle theta, sine theta is 1 over 6. Sine theta is opposite over hypotenuse. That tells me that the opposite, if the opposite is 1, then the hypotenuse must be 6, because their ratio is 1 over 6. So using Pythagoras, I can get this third side. So it's going to be square root of the hypotenuse squared minus the side squared. So square root of 36 minus 1, which is root 35. From here, it's very easy to find cosine theta. So cosine theta from so katoa, ka means cosine equals adjacent over hypotenuse. So cosine is going to be adjacent, which is root 35 over hypotenuse, which is 6. So secant theta is basically the opposite of that. So it's 6 over root 35. That is going to be secant theta, and this is my answer over here. Now, the question tells me find the exact value of cosine 2 theta. Again, here I can see a double angle, so let me see if I can find something that is going to help me in the double angle formulas over here. So question wants the cosine 2 theta. So cosine 2 theta, I can write it in numerous ways. I can write it like this, I can write it like this, or I can write it like that. So from the previous question, I already got what is sine theta. Sine theta was 1 over 6. So if I write cosine 2 theta as 1 minus 2 sine squared theta, I can find the value. So this is the identity that we're going to use. Double angle identities we're going to use a lot. Sum and product identities, not really. We are going to use the sum to product a little bit, and we are going to use the sum and difference a little bit. These two are not much, it's good to know. And we're going to use the Pythagorean identities a lot as well. Any other identities? These are the main identities that you should focus on, and of course the reciprocal identities. Anyways, so cosine 2 theta could be written as 1 minus 2 sine squared theta. I know that sine theta is 1 over 6, so this is 1 minus 2 into, instead of sine theta, I'm going to put 1 over 6 squared. So this is going to equal 1 minus 2 over 36, because 1 squared is 1, 6 squared is 36. So 1 minus 2 over 36, that's going to give me 17 over 18. And that is going to be my final answer. Yeah, this is the final answer over here. Now, let's get rid of this and let's get into the next question. So this question tells me, solve the equation 7 cotangent theta equals 3 cosecant theta for theta between 0 and 90. So in our question over here, we are going to use the ASTC rule a lot, okay? And I've done a full comprehensive video on ASTC rule. I'm gonna leave its link on the top right hand corner. Feel free to go and check it out. Let's see if we will need it in this question over here. So 7 cotangent equal 3 cosecant theta. So whenever I don't know how to start, I will always start by changing everything to sine and cosine, and see, this is a trial and error. I'm gonna see if that's going to help. So let me try and do that. So this is gonna be 7 into, cotangent is basically the inverse of tangent. So if tangent is sine over cosine, cotangent is gonna be cosine theta over sine theta. This is going to equal 3 into cosecant theta is basically 1 over sine theta. So over here, what's going to happen is that sine theta and sine theta are going to cancel, and I'm going to have 7 cos theta equals 3. So cosine theta equals 3 over 7. Now, to get the first value of theta, we're going to do cosine inverse 3 over 7. So if you put that on the calculator, make sure our calculator is in degrees, because our range is in degrees. So shift cosine 3 over 7 is basically 64.6 degrees, and there is no other solution in this range, and I'm going to teach you how to know that in the next questions. Okay, let's move on to the next question, which is a little bit harder. Let's see how we can approach this question over here. So I have a secant squared theta plus tan squared theta equals 5 tan theta plus 4. I know that secant squared theta, I think it's written in the identities over here. Let's go check them out. So secant squared theta, no, it's not written here. Basically, secant squared theta is equal to 1 plus tan squared theta. So that's going to help me to have everything in terms of tan, and then I can solve. So instead of secant theta, I'm going to put in 1 plus tan squared theta, and then I have a plus tan squared theta equals 5 tan theta plus 4. So this is starting to look like a quadratic, and this comes a lot in trigonometry. So I'll show you what I mean. So over here, I'm going to put everything on the left side. So this is going to be 1 plus tan squared theta plus tan squared theta is 2 tan squared theta. And then I'm going to move this 5 tan theta. The other side becomes minus 5 tan theta, and then minus 4 equals 0. So 1 minus 4 is basically negative 3. So I'm just going to remove that and just put in negative 3 over here. This is starting to look like a quadratic. Why? Because a quadratic looks something like this. 2x squared, ax squared, so ax squared plus bx plus some constant. Here I have tan squared, and I have tan, and I have a constant. So this is very similar to a quadratic. So what you can do is you can solve it just like how when you use your quadratic formula to solve for x, you can use a quadratic formula. However, instead of x here, we have tan theta, right? So when you use your quadratic formula, you're not going to get values for theta or answers for theta. No, you're going to get answers for tan of theta. Other people like to do this. They come here and say, okay, what we're going to do is we are going to name x as tan theta. So this question becomes 2x squared minus 5 times tan theta, which is basically x, minus 3. Now this is a quadratic. They solve it. They get 2x values. Let's say 1 and 2. And then what they do is they come, okay, x is tan theta. So instead of this x, I'm just going to put tan theta equals to this, and tan theta equals to that. This is another options. You can do whatever you like. However, this, I feel like it's an extra step. If you're a beginner, you can do that. If you are feeling comfortable with using tan theta straight away, you can do that as well. So let's solve this using the quadratic formula. So it goes like minus b plus or minus square root of b squared minus 4ac over 2a. So over here, my b is negative 5. So negative b is just 5 plus or minus square root. B is negative 5 squared minus 4 times a, which is 2, times c, which is minus 3, over 2 times 2. So here I'm going to get two values, one when this is plus and one when this is minus. So the two values are going to be, so my tan theta is going to equal 5 plus square root of 5 squared minus 4 times 2 times negative 3 over 2 times 2. First answer is going to be tan theta equals 3. And the second answer is when I replace this middle plus into a minus, it becomes tan theta equals negative 1 over 2. So the question wants me to solve the equation. Solving means getting theta. It's not getting tan theta. So I still have to solve these two equations, keeping in mind this range over here. So what we're going to do, we're going to solve each equation on its own. So tan theta equals 3. Let's put them this direction. So tan theta equals negative half. So tan theta equals 3. Doing shift tan 3 is going to give me theta. So shift tan 3 is going to equal 71.57 degrees. Okay. Does it say any? Yeah. So 71.57 degrees. Now, if I do that for here, so shift tan of minus half, shift tan of minus 1 over 2, that's going to equal minus 26.57 degrees. However, my range is from 0 to 180, so clearly this is outside of my range. So to get the other solutions, okay, because you know that trigonometric functions are repeated, okay? So we don't have only one solution. So when we say tan theta equals 3, that means we want to find the thetas where y equals 3. So we can find this solution, that solution, that solution, this solution. So we have endless solutions. That's why we're given a range. So we need to find all the solutions inside our range, and we use the ASTC rule to help us find that. So let's use the ASTC rule to find the other solutions for this part. So we do our S, T, C. A stands for all, S is sine, T is tan, C is cosine. So my tan theta is equal a negative answer. So in which quadrants is tan going to be negative? All means all positive. T means tan only positive. So tan is going to be negative in the sine quadrant and in the cosine quadrant. Okay, so my first angle, my first answer is negative 26.57. So I start from my x-axis and I go clockwise because it's negative. So I go clockwise 26.57 degrees. That is my first solution. And here by symmetry, this is also going to be 26.57 degrees. Okay. Now to find the other solutions, first, I'm only looking for positive solutions, right? So I'm always going to start from my x-axis. Whenever I rotate clockwise, I'm getting the negative solutions, okay? Just like here, I rotated clockwise 26.7. That's why the answer is negative 26.7. So if I want the positive solutions, I should rotate anti-clockwise until I hit one of the lines. So to rotate anti-clockwise, starting from here, all the way until I hit the line, this is going to be my answer. This is going to be my angle. So how much is this angle? I know that this whole thing is 180. So to find this angle, I need to subtract 26.57 from it. So the theta is going to equal 180 minus 26.57. That is going to give me an answer of 153.4 degrees. And that is going to be the answer. And if you put on your calculator tan of negative 26.57, it's going to give you negative half. And if you put on your calculator tan 153.4, it's also going to give you negative half. You can try that if you want to make sure. So this is how you use the ASTC rule. It's very, very, very important to understand it. And we're going to solve lots of questions on it today. So stay around and stick around so you can practice. All right. Let's try this question over here. So this question says that 2 cosecant 2 theta cotangent theta is equal to cosecant square theta. We are supposed to show that. So how are we gonna show that? First, let me write everything in cosines and sine. That's my usual starting point, and noticing that I have a double angle over here. So cosecant is basically sine, 1 over sine. So this is going to be 2 times 1 over sine 2 theta. Multiply cotangent theta is basically cosine theta over sine theta. And this is going to equal cosecant squared theta. So cosecant squared theta is basically 1 over sine squared of theta. So we need to show that this left side is equal to this right side. So let's start working on the left side. I see that my right side is only in terms of theta. There is no double angle. So that's a very good indication that I should use the double angle identity over here. So 2 over, instead of sine theta, I'm going to use the double angle identity, is equal to 2 times sine theta times cos theta, and then times cosine theta over sine theta. So the 2 and the 2 will cancel, the cosine and the cosine will cancel. So I'm going to have 1 over sine theta times sine theta is sine squared theta, which is equal to 1 over sine squared theta. That's how I can show that these two sides are basically equal. Now, it says, hence show that cosecant squared 15 degrees times tan 15 degrees equals to 4. So it says hence, so you probably I'm going to use the previous part. So the previous part has a cosecant squared theta and it's equivalent to this form. So what I can do is I can use, this is also cosecant squared of theta, so I can change it to the other form and start solving. So let's see how I can do that. Let me okay, so we said that this is equal to 2 cosecant 2 theta. So we said from the previous part, cosecant squared theta is equal to 2 cosecant 2 theta cotangent theta, right? So let's see how will that help us. So let's change this into this form. This is going to be 2 cosecant 2 theta. Theta is 15, so 2 times that is basically 30. And then cotangent theta, which is 15, multiply tan 15, and we need to show that it's equal to 4. So the cosecant theta, I'm going to change it to sine, so it's going to be 2 over sine 30. Cotangent is basically 1 over tan 15 times tan 15, so these two clearly will cancel out. So I'm going to have 2 over sine 30. What is sine 30? Sine 30 is basically half. This is similar to 2 divide half, which is the same as 2 multiply 2 over 1, which is equal to 4. This is how we have shown this. Okay, this next part is tricky, so let's see together how can we attempt to solve it together. Okay. So this question says, solve the equation 2 cosecant phi cotangent half phi plus cosecant half phi equals 12. Okay, straight away, this is similar to what I have done over here. Let me put it both in the screen. So over here, I can see that 2 cosecant double of an angle, so 2 cosecant phi cotangent half of that original angle. So if the original angle is phi, then cotangent should have half of phi, right? This is very, very similar. This is very similar to this. So this is a clue in the question that I can use the fact that this is equal to that. Maybe that is going to help me. So let me change all of this, okay, knowing that the angle theta is half of phi, okay, because this angle is twice theta, and this angle is the theta angle. So what we're going to do is we're going to change all of this into what? Into cosecant squared of the angle itself, which is half phi, plus cosecant half of phi, and I can bring this 12 to this side, so minus 12 and equate to 0. So now if you notice, this is also looking like a quadratic question with x equals cosecant half phi. So we can use the quadratic formula to solve for cosecant half phi. So quickly, it's going to be minus b. B here is basically 1. So minus 1 plus or minus square root of 1 squared minus 4 times a is also 1. And c is negative 12 over 2 times a, so 2 times 1 is basically 1. So I'm going to get two solutions over here. If I put this, the first solution is going to be over 2. So the first solution is going to be when cosecant half phi is equal to 3. And the second solution is going to be when cosecant half phi is equal to negative 4. However, here, our range is huge. Our range is from negative 360 to 360. So obviously, we're not going to have just one solution. So we're going to have to use the ASTC rule. However, I don't like working with cosecant. Let me change it quickly to sine. So I know if I will change this to sine, it's going to be 1 over sine 1 over 2 phi equals 3. So the sine itself is going to be 1 over 3. So sine half phi 1 over 2 phi is equal to 1 over 3. And similarly here, sine 1 over 2 pi is equal to negative 1 over 4. Let's solve each one on its own. First of all, I do not like anything to be over here. This is always, I don't want to be a sine phi plus something, sine half phi, sine phi squared. I just want a single thing. Sine x, sine phi, sine theta. So let's see how we can change this. So what I'm going to do is I'm going to say half phi, I'm going to name it as y. Okay, so this, instead of sine half phi, is going to become sine y equals 1 over 3. Okay, but doing this, I need to change the range as well. My range was negative 360 to, let me write it over here. So the range is negative 360 to phi into 360. So I'm not looking for phi, I'm looking for half phi. So I'm multiplying here by half, so I need to multiply both sides by 1 over 2 as well. So this becomes minus 180 less than half phi less than 360. And half phi is basically y, so minus 180 y, sorry, this should be times half as well, so this is 180. So half 180 as well. So this is my new range that I will solve for y, and after getting the solutions for y, I'm going to change to get the solutions for phi again. So I'm going to use this range. Let me copy it over here. So y is basically from negative 180 to 180. Y is negative 180 into until 180. So now, solving sine y equals 1 over 3, getting all the answers in this range. So the first answer is going to be shift sine 1 over 3. So shift sine 1 over 3 is basically 19.47 degrees. That is my first answer. Let's use the ASTC rule. ASTC. I know that sine y is equal a positive answer. So I will need the quadrants where sine is positive. So that's going to be the sine quadrant and the all quadrant. And my first answer was positive 19.47. So from the positive x-axis, I move anti-clockwise 19.47 degrees. By symmetry, this is also 19.47. So let me start getting the next answers. So from here, I'm going to move clockwise. Okay, this is the first answer. I already did it. So I'm going to skip this and go to the next answer, which is going to be all of this angle, which is basically 180 minus 19.47. That's going to give me another y value of 180 minus 19.47. That is going to equal 160.53 degrees. That is why. Let me ask you a question. Is there any positive answer here within my range? The 19.47 is in my range. It's between negative 180 to 180. The 160 is also in my range. Is there any other positive answer? So not the first answer, not the second answer, continuing, doing a full 360 and then adding 19.47. That's obviously outside of my upper hand. So that's it for the positive answers. Two positive answers. Now, let's try to look at the negative answers if they're going to be in our range. So we start here moving clockwise. Okay, I passed the 180. So I passed the negative 180. So this is also outside of my range. So I only have these two values for y for the first part over here. So the first part is done. I got the two y values. Let's solve for this part as well. So again, sine y is equal negative 1 over 4. So the first principal answer is going to be shift sine 1 negative 1 over 4. So shift sine negative 1 over 4 is equal minus 14.48 degrees. That is my first answer. Let's do the ASTC rule to get the rest of the answer, because the calculator is not going to give you anything. It's just going to give you one answer. You have to get the rest. So sine is equal something that is negative. So where is sine going to be negative? In the tangent and cosine quadrants, right? And the first answer makes sense. It's clockwise 14.8 degrees, and this makes sense, 14.48 degrees. This is also 14.48 degrees. Let's get the other answers. Let me ask you, if we go anti-clockwise to get the positive answers, we did a full 180 and then we need some more. So this is also outside of our range. So there are no positive answers here. The next answer is going to be this angle over here, which is going to be 180 minus 14.8. So 180 minus 14.48 is equal to, so the next y, so the next y is going to equal, let's actually put it in red. So next y is going to equal 165.52. However, we rotated in the clockwise direction, so this must be a negative value, and I don't have any other answers. These are the 4 answers for y. Am I done? No, the question asks for the solution for theta, so we need to get, sorry, phi, it's not theta, this is phi. So phi is basically equal 2 times y. So here, if y is 19.47, phi is going to be 19.47 times 2, which is around 39 degrees. Here, phi is going to equal 160.53 times 2, which is 321 degrees. Here, phi is going to equal negative 165.52 times 2. That is going to equal minus 331 degrees. And for the final answer, which was this one, phi, let's put it here, is going to equal negative 14.48 times 2, which is negative around negative 29 degrees. These are all the correct answers that you should see, and these answers are always going to be in the same, within the original range. You will never, if you did everything correctly, you will never find an answer for phi that doesn't is not included in the original range. All right, very good. Let's move on to the next question. First, let me erase this part. All right. Let's take a look at this question over here. Question says solve for, this is the range, including 360, 2 tan theta plus 3 sine theta. So let's see how we can attempt that. I don't have any ideas right now, so let me just change the tan into sine over cosine and see what I can get. So it's going to be 2, so this is part A, 2 sine theta over cosine theta plus 3 sine theta equals 0. So over here, I can see if I multiply everything by cosine theta, let me try to do that. So to get rid of the cosine theta on the denominator, it's going to be 2 sine theta plus 3 sine theta cosine theta equals 0. I can factorize this taking sine theta out, so I'm going to be left with 2 over here plus 3 cosine theta, and that is equal to 0. And from factorization, you know, when I have 2 terms multiplying each other, either this term has to be the 0 term or this term has to be the 0 term to give me a final answer of 0. So sine theta equals 0, or 2 plus 3 cosine theta equals 0. When I solve these two equations, this is going to give me my answers over here. So sine theta equals 0. If you do shift sine 0, that's going to give you an answer of 0. Right? However, 0 is not included in our question over here, so I'm not going to take it. So what I'm going to do is, this doesn't need the ASTC rule, just the basic knowledge of the sine graph. So this is 0, this is 90, 180, and this is 270 and 360. So where sine is 0 is basically going to be at 180 and 360. So theta equals 180 degrees and theta equals 360 degrees are going to be my answers to this first part. Now for the second part, I'm gonna solve this equal to 0. So I'm gonna move the 2 to the other side and divide by 3. So cosine theta is gonna equal negative 2 over 3. Now here, theta is going to equal shift cosine, or cosine inverse of negative 2 over 3. That's going to give me an answer of 131.81 degrees. That is inside our range, so I'm going to accept it. So I'm going to accept this answer. However, let's see if we will have another answer. So we need to use the ASTC rule. So ASTC C. Cosine theta is a negative answer, so cosine is negative in the sine and the tan quadrants. The first principal answer is going to be positive 131. So from the positive x-axis, I'm going to move anti-clockwise since it's positive 131. This angle is 131.81 degrees. So that leaves me with this angle as 180 minus 131.81. That is 48.19. And this is also 48.19. So first of all, my range is from 0 upwards, so I don't want any negative answers, so I'm not going to even bother to move in the clockwise direction to get this answer. What I'm going to do is I'm going to get the next positive answer, which is not this one, is going to be this one. So I did a full 180 plus this bit, which is 48.19. So 180 plus 48.19 is equal to 220, around 228. So that is also another answer. So 228 degrees. So all the answers, if I'm going to put them in order, so 180, 360, and I have a 131. Let's round it to 132 degrees and 228 degrees. These are going to be my final answers for this question. Alright. Let's move on to the next question over here. So this question says, solve, and it gave us a range and it looks like it's in radians, so we need to set our calculators accordingly. Solve this equation over here. So let's see, right? So sine, let's actually use this. Yeah. So sine 3 theta minus root 3 cosine 3 theta equals 0. I'm glad that they are both 3 theta. That is good. So I'm going to move this to the other side. It's going to become positive. So sine 3 theta equals root 3 cosine 3 theta. So I know that if I divided cosine 3 theta from both sides, I'm going to end up with a tan 3 theta on this side, which is what I want. I want everything to be only one trigonometric function, okay, in order to solve. So that's what I'm doing. I'm changing everything to tan 3 theta equals basically root 3. So now I'm very close to have a perfect scenario to solve. However, the only issue is that this is a 3 theta, and I told you I don't like having anything besides an x, a y. I don't want anything multiplied to it, anything added to it, subtracted, or whatever. So what we are going to do is we are going to say that 3 theta is going to equal y, okay? And we also need to adjust our range. So from 0 theta to pi, so this is our original range, pi. If I wanted as 3 theta, I need to multiply by 3 on both sides. This is going to be 0 as well, and this is just basically going to be 3 pi. So this is my new range. Now my equation goes like this: tan y equals root 3 and then instead of 3 theta, I'm just going to put in y. For this range, this is a whole new equation that I created to solve, and then we're going to change from y to theta later on. So to solve this, I'm going to do shift tan root 3. I'm going to get my first answer, which is pi over 3. So y is equal to pi over 3. That is the first answer, and my range here is huge. So obviously I will need to use the ASTC. However, I don't have any negative answers. They're all positives. And I know that tan is equal to a positive answer. So tan is positive in the all and the tan quadrant. My first answer is pi over 3. So this angle, I'm going to move anti-clockwise because it's a positive answer. So pi over 3. This makes this angle as well as pi over 3. Okay. Now, let's start by getting the next angle. I'm going to ask you, is it correct for me to move this way to get this angle? No, because my range ends at 0. I cannot go below 0, and moving this way means I'm moving clockwise, so I'm getting a negative answer. So I'm just going to move that way, okay? So the next answer is going to be a full 180 or pi plus this bit, which is pi over 3. So I'm going to have my next answer as pi plus pi over 3, which is 4 pi over 3. I'm still below 3 pi because 4 over 3 is less than 3, obviously. So what we're going to do is we're going to solve for the next one. So not the first one, not the second one. We're going to keep continuing. So we did a full rotation. We did the full 2 pi rotation over here. And then we have to move an extra pi over 3. So the third answer is going to be 2 pi plus the extra pi over 3. That's going to give me 7 pi over 3. And then 7 over 3 is still lower than 3 pi, so I'm still in the range. However, if I'm going to go to the next one, so I'm going to move let's say the fourth answer, so I'm going to move full 2 pi. This answer I already got, so I need to move another pi, so that's 3 pi now and a bit extra. So now I'm definitely outside of my range. So these are my 3 answers over here, but these are in terms of y. I need to get in terms of theta. So theta from here is equal to y over 3. So this is going to equal pi over 3 divided 3 is basically pi over 9. 4 pi over 3 is basically 4 pi over 9, and 7 pi over 9. This is going to be my 3 answers over here, and they are definitely within my range. Okay, let's solve part double I. Part double I says that, wait, I think yes, actually in the previous question, I missed part B, so it's very easy. Just let's do it quickly. So the question, the answer we got for part A was was theta equals 131 degrees, 228 degrees, 360 degrees, and 180 degrees. So this question says, hence or otherwise, part B, find the smallest possible solution of this part. So basically this is the same as, so 2 tan theta, 2x plus 40. 3 sine 2x plus 40. So basically 2x plus 40 is similar to theta. So if you want the smallest positive solution, I know that I'm going to use for this one, because I'm going to subtract 40 and then divide by 2. So I want the smallest theta solution. So 2x plus 40 equals 131. So 2x equals 131 minus 40 is basically 91. So x is going to equal to 45.5 degrees. That is going to be my answer. Super sorry for that. Let's continue our question over here. So we found part double I. Let's continue to part double I. So this question says, given that 4 sine squared theta plus cosine x, 4 sine squared x plus cosine x equals 4 minus k, find cosine x in terms of k. Okay, that is interesting. Let's see how we can do that. First of all, I know this is a cosine x and this is a sine squared of x, so I want everything to be a single function. So I know that sine squared x plus cosine squared x equals 1. So I can change this sine squared x as 1 minus cosine squared of x. So this is going to be 4 into, instead of sine squared of x, is going to be 1 minus cosine squared of x plus cosine x. And then I'm going to move this everything to one side, so minus 4 plus k. So this is going to be 4 minus 4 cosine squared x plus cosine x minus 4 plus k equals 0. So let's actually have the cosine squared term as positive. So I'm going to actually move everything, or actually no, let me just do the 4 minus the 4. That's going to be 0. So I'm going to be left with minus 4 cosine squared x plus cosine x plus k equals 0. This is starting to look like a quadratic. Always in quadratics, I don't want to have a always in quadratics, I don't want to have a negative sign, so I'm going to multiply everything by -1. So this becomes plus, this becomes minus, this becomes minus, and this is my answer over here. The question asks me for a solution for cosine of x, not x. It just wants the solution for cosine of x. So over here, cosine of x, I can find it using the quadratic formula, because this is looking like a quadratic. So I'm going to do minus b is going to equal minus b. So minus -1 plus or minus square root of b squared, so -1 squared. Why -1? Because the term that's multiplying the cosine x is -1. The -4 times a is basically 4 times c, which is minus k, all over 2 times 4. So this is basically +1 plus or minus square root of 1 squared is 1. -4 times 4 times minus k is plus 16k over 2 times 4 is 8. So this is basically going to be the solution in terms of k. So this is going to be my final answer over here. Now, the last part tells me when k equals 3, find the values of x. So now I'm trying to solve for x within this range. So k is 3. So straight away, cosine x is equal to 1 plus or minus square root of 16 times 3 is 48, plus 1 is 49. So square root of 49 over 8. So that's equal to 1 plus or minus 7 over 8. So the first answer is going to be when this is plus. So cosine x equals 1 plus 7 divided 8 is basically 1. So 8 over 8, which is 1. Or cosine x is going to equal 1 minus 7 divided 8, which is going to give me an answer of -3 over 4. My range is 0x till 360. Let's solve. So where is cosine x going to equal 1? We know that cosine looks like this. This is 0. This is 90, 180, 270, and 360 degrees. So it's equal to 1 at 0 and at 360. However, 360 is outside my range. So my only answer for this part is going to be x equals 0. So x equals 0 degrees over here. Right? Now for the next part, cosine x equals -3 over 4. The principal answer, or the first answer, is cosine inverse of -3 over 4. That's going to give me an x of, let's change it to degrees. So x equals 138.6 degrees. That is the first answer and is within our range. Let's see if we will have more answers. So A, S, T, C. Cosine is equal negative. So cosine is negative in the sine and the tan part. First angle is positive 138. So 138 anti-clockwise from the positive x-axis. That means that this is 180 minus 138.6, which is 41.4 degrees. And this is also 41.4 degrees. My range is until 0, so I cannot go below 0. So I'm not going to even bother getting the clockwise answer. So I'm just going to keep on doing the anti-clockwise ones. So this one seems like it's a 180 plus this 41.4. So the next answer is going to be x equals 180 plus 41.4. This is equal to 221.4 degrees. So my answers over here are basically going to be x equals 0, x equals 221.4, and x equals 138.6. These are the final answers. Okay, let's move on. Let's delete this as well. We're done. Let's erase a little bit. So let's move on to the next question. This question says express. Okay, so this is also a form of identities. It says express 4 sine theta plus 4 cosine theta in the form of r sine theta plus alpha. So this part shows me that there is an addition inside the sine. So let me look at the identities. Let me actually get them a bit closer. So these are the identities. Let me put them over here. So let me look at the identities that might help me. So sine of an angle plus another angle looks like it's this identity over here. So r sine theta plus alpha is going to equal r into this whole thing. So sine x plus y is equal to sine x cosine y plus cosine x sine y. This is going to equal sine of the first angle, which is sine theta, cosine of the second angle, so cosine alpha, and then this is plus cosine of the first angle, which is theta, times sine the second angle, which is alpha. So over here I have this. So if I multiply the r on both sides, I'm going to have r, let's put it as r cosine alpha sine theta plus r sine alpha cosine theta, and this should all equal this part, 4 sine theta plus 4 cosine alpha. So by looking and by observing both sides, you will find that the sine theta term here is multiplied by r cosine alpha, and the sine theta term here is multiplied by 4, right? And then there is a plus, something multiplying cosine theta, something multiplying cosine theta. So they're exactly the same. So this must mean that this part should equal to the 4 over here, and this part should equal to the 4 over here. So what we're going to have, let's do this part first. So we're going to have r sine alpha is equal to this 4. So it's equal to 4. And we have r cosine alpha is equal to also this coefficient. So it's equal to 4. So what I can do is I can divide both equations together. So r's are going to cancel. Sine cosine over each other is basically tan alpha is equal to 4 over 4, which is 1. So to get alpha, shift tan of 1, that is going to give me alpha as 45 degrees. Now I found alpha, I need to find r, so I can use any equation of those. Let me use this one. So r is going to equal 4 over cosine alpha, which is basically cosine 45. So 4 over cosine 45 is going to give me an answer of 4 root 2. So r is equal to 4 root 2. So basically this whole thing is going to equal 4 root 2, which is the r, times sine of theta plus 45 degrees. So this is how to solve this question. Now, this question tells you, part I says, hence find the smallest positive value of theta satisfying this equation. So since it says hence, okay, I will need to use the previous part. I know that 4 sine theta plus 4 cosine theta is equal to this. So I'm just going to straight away put 4 root 2 sine theta plus 45 equals 5. And let me try to get the smallest positive value for theta. So I'm going to start by dividing 4 root 2 from both sides. So 5 divide 4 root 2 is going to equal 5 root 2 over 8, and this is equal to sine theta plus 45. So straight away I can solve. I have everything in terms of one function. However, again, I don't like lots of things inside the sine. I just want one single thing. So I'm going to do what we do always, is just say that theta plus 45 is going to equal to y. And now our range, we have a range. No, it just wants the smallest positive value. So we don't need to do anything for the range. So sine y is going to equal 5 root 2 over 8. So So the principal answer is going to be shift sign 5 root 2 over 8. So the y is going to equal 62.1 degrees. And if you want to make sure, you can use the ASTC rule. However, you won't find. So ASTC rule quick. ASTC, sign is positive here and here. This is the first answer. The second positive answer is going to be way bigger than it. So that's the smallest positive answer for y, which is going to be the smallest positive answer for theta as well. So theta is equal y minus 45. So y, which is 62.1 minus 45. So my final answer is going to be 17.1 degrees. That is my final answer for this question. Let's see if there is another part. I don't remember. Probably there is. Yes, so there is a part B. Oh, it's actually a 6 marker. Okay, this one is tough. Okay, let's see how we can solve this one. So straight away, I can see that I have a 4 cotangent 2x equals 5 plus tangent x. Cotangent and tangent are related. So let me start by just rewriting this as 4 over tan 2x, because I know cotangent is reciprocal of tan. This is equal to 5 plus tan x. My only issue here is that this is a 2x and this is an x, so I need probably to use the double angle formula for tan. So let's see, it's basically right over here. So tan 2 theta is equal to 2 tan theta over 1 minus tan squared theta. So this is going to be 4 over, instead of tan 2x, I'm going to put in 2 tan of x over 1 minus tan squared of x. And then this is all equal to 5 plus tan x. So to rewrite this, I'm going to put this whole thing on top. So this becomes basically 4 into 1 minus tan squared x over 2 tan of x equal 5 plus tan x. Everything is in terms of tan x, which is great. So what I can do is I can multiply 2 tan x both sides to get rid of it in the denominator. So this becomes 4, and let's multiply this. So 4 minus 4 tan squared x equals 5 times tan x plus tan squared of x, because I multiplied tan x to the whole right side. So let's move everything to the right side. So this becomes 0. This becomes a positive 4 tan squared plus 1 tan squared is basically 5 tan squared x plus 5 tan x. And over here, I basically have a... Oh, I should have multiplied everything by 2 tan x. So there is a so this becomes it's not only multiplied tan, so this becomes a 10, and this one becomes a 2 tan squared of x. That's why. So moving everything to the right hand side, 4 tan squared plus 2 tan squared is 6 tan squared x plus 10 tan x, and then moving this 4 to the other side becomes just a minus 4, and this is again starting to look like a quadratic. Let's solve it real quick. So minus b minus 10 plus or minus square root of b squared 10 squared minus 4 times a, which is 6, c, which is negative 4 over 2 times 6. So that will give me 2 answers for tan of x. So quickly, minus 10 plus square root of 10 squared minus 4 times 6 times minus 4 over 2 times 6. First answer is tan x equals 1 over 3. Second answer is tan x equals negative 2. Now I will need to find the other solutions. Let me see what is my range. My range is in radians from 0 to pi. So the first solution for tan x equals 1 over 3. Let's change it to radians. Shift tan 1 over 3 is equal to, so x is going to equal to 0.3 2 radians. Okay, now let's see if we can get the other answer. So ASTC, tan is positive 1 over 3, so tan is positive in the all and in the tan quadrants, so this is 0.32 positive, this is also 0.32. So the next answer is actually going to be outside of our range. Our range is from 0 to pi. So if I'm going to move to the next one, I'm going to go pi and then a little bit more. So I'm going to exceed pi. And this way is going to give me a negative answer, and my range is 0 as its lower bound. So for this part of the question, x equals 0.32 is the only answer over here. For the second part, let's do shift tan of negative 2. That's going to give me an x of negative 1.1 radians, which I need to neglect or reject because this is outside my range. However, I can use ASTC rule to get another value that is inside my range. So tan is negative 2 now, so tan is negative in the sine and the cosine quadrant. The first principal angle is minus 1.1, so from the x-axis we move negative 1.1. So is it anti-clockwise or clockwise? If you said clockwise, you are correct. So this is 1.1. We need to start from the tan, move anti-clockwise until this part. If this is 1.1, this is also 1.1. So if we want this angle, it's going to be pi minus 1.1. So pi minus 1.1 is 2.04. So the next answer is x equals 2.04 radians. And this is going to be the final answer for this question. Okay, very, very interesting. This is the final question. Okay, that's the final question for today. Let's attempt it. So this question says that solve for 0 to, do I have any other questions? No. Okay, perfect. So solve from 0, x is greater than 0, less than 360. Yeah, we need to solve sine x tan x equals 5. Let's do it over here. That's interesting. So let's start by solving part I. So it says that sine tan x equals 5. So straight away I'm going to change tan x into sine over cosine. It becomes sine x times sine x over cosine x equals 5. This becomes sine squared of x over cosine x equals 5. Straight away I can use the identity, the Pythagorean identity, which says that 1 minus cosine squared of x is the same as sine squared of x over cosine x equals 5. So I'm going to multiply cosine x to every side. So 1 minus cosine squared of x equals 5 cos x. Move everything to the right hand side to have this term as positive. You guessed it, now it's quadratic. So cosine squared of x plus 5 cosine of x minus 1 equals 0. I'm going to solve this in the quadratic way. So minus 5 plus or minus square root of 5 squared minus 4 times 1 times minus 1 over 2 times 1. It's going to give me two answers, which are basically so the first answer is going to be cosine x equal basically minus 5 plus or minus square root of 29 over 2. Yeah, because 5 squared is 25, 25 plus 4 is 29. So this is the answer. So cosine x is 1 time plus, 1 time minus. So let's try to solve cosine x equals minus 5 plus root 29 over 2. So to get x, I'm going to shift cosine minus 5 plus root 29 over 2. That's going to give me an x value of 78.9 degrees. Okay, and let's do the ASTC rule. STC, I know cosine is basically, okay, this if you put it in the calculator is going to give you 0.19, so it's a positive answer. So cosine is positive in all, and cosine, this is 78.9, this is also 78.9. let's move in the positive direction. This is basically 270 plus this bit, or actually better, let's say this is all 360 minus 78.9. So the second x is going to be 360 minus 78.9, which is 281.1 degrees. The other answer, when you try to solve cosine x equals negative 5 minus root 29 over 2, minus this whole part is equal to minus 5 point something, and we know that cosine x goes only to 1 and minus 1, so this gives you a math error. So this part is not going to give us any solutions, so our only two solutions are basically these two solutions. Now, we can erase all of this in order to solve the second part of this question. So, let's read the second part after finish. Yeah. All right. So, this question, part II, says, given this figure, okay, shows it's a sketch of y equals, it's a sine function with some modifications. So the modifications, I'm gonna do a video on them because they're very, very important to know how to get the period, how to get the amplitude, how to get the horizontal shift, the phase shift, the vertical shift and the phase shift, and so on. So it says that A is a constant. A denotes the amplitude here, and theta is measured in radians. Points P, Q, and R lie on the curve, given that the y-coordinate of P is 7. So this is 7. Does that mean that the graph goes to 7 and minus 7? No, it doesn't look like it. And the reason for this is this vertical shift over here. I'm going to show you. Okay, the first question says, state the value of A. Okay, for the amplitude for a normal sine function is basically the distance from the 0 line until the maximum, which is 1. That's why the amplitude of 1. If we want to graph sine, 2 sine of x is basically going to be until 2 and minus 2. So the distance between the 0 line and the 2 is going to be the amplitude. Okay. What if we want to graph sine 2 sine of x plus 1. This plus 1 means that now our whole thing is shifted up by 1. So instead of the x-axis being our equilibrium position or the 0 position, it's now x equals 1. So this is how we start our sine function now. Okay. The amplitude is 2. It means that from the 0 position, however, it's from the new 0 position, which is lifted 1. It's 2 units up, so this is actually going to be 3. And here it's going to be 2 units down, so this is going to be minus 1. So this is how you need to take care between the amplitude, and you have to take extra care for the amplitude when there is a vertical shift, just like our question over here. So our question says what? Says that there is a vertical shift of 2. So now our 0 line is actually here at x equals 2. And this is at the 0 line is at y equals 2. And the maximum point was at y equals 7. So what's the distance between the 0 line and the maximum point? It's 7 minus 2, so it's 5. That is why A equals 5. It's not 7, it is 5. So it's 5 this way, and it should be 5 that way. So 2 minus 5, this part should be minus 3. Okay? This is how you solve. The question says, find the exact coordinates of Q. Okay, we need to find the exact coordinates of Q. First of all, we know that the y-coordinates of Q is minus 3. So Q is something and minus 3. Now, to solve this, let's solve for the theta values for Q. So let's solve it over here. So first of all, the equation is y equals A is 5 sine 2 theta minus 3 pi over 8 plus 2. Now we want to find the theta values when y is minus 3. So we substitute y over here with minus 3 equals 5 sine 2 theta minus 3 pi over 8 plus 2. So what I'm going to do is going to move this 2 to this side and then divide by 5. So this becomes minus 5 equals this part. And then divide 5 is going to equal sine 2 theta minus 3 pi over 8. So basically sine, let's actually call 2 theta minus 3 pi over 8, let's call it as y. Okay, so sine y is going to equal minus 1. Now, since I changed this, I have to change my... Actually, no, there is no range over here. We just want to find the exact coordinates of Q. Okay, so now we need to solve for sine y equals minus 1. So over here, I know that when is sine minus 1? So sine is a function that looks like this. So it's going to be minus 1. So this is 0. This is pi over 2. This is pi. And this is 3 pi over 2. So it's basically at 3 pi over 2, right? So y is equal to 3 pi over 2. So let's actually say that from here, theta is going to equal y plus 3 pi over 8, all divided by 2. So if y is 3 pi over 2, theta is going to equal y, which is 3 pi over 2 plus 3 pi over 8, all over 2. That's going to give you an answer of 15 over 16 pi. So theta is going to equal 15 over 16 pi. And that is going to be the answer over here. Okay. Now, part C is a little tricky. So let's see how we can attempt it together. Let me just erase. Okay. Part C says, find the value of theta at R, giving your answer to 3 significant figures. So this is clearly when the y is equal to 0. So again, our y is equal to 5 sine 2 theta minus 3 pi over 8 plus 2. So we want to find the answer where y is 0. However, we have a couple of answers. 1, 2, 3. We have 1, 2, 3, and our answer is the fourth answer, fourth positive answer. So we need to take that into consideration. So instead of y, I'm going to put in 0 equals. So equals all of this. So I'm going to move the 2 to the other side and divide by 5. So actually is going to equal minus 2 over 5 equals sine. Let's name this as y. So this is going to equal y. Right? So y again is equal to 2 theta minus 3 pi over 8. So theta is equal to y plus 3 pi over 8 all over 2. Okay, now the first answer for y is going to equal shift sine negative 2 over 5. That's going to give me an answer of, we need to change it to radians. That's going to give me a principal answer of negative 0.41. Now, let me do my ASTC. So ASTC, my sine is negative. So sine is negative in the tangent and cosine quadrant. The first answer is minus, so clockwise 0.41. So this is also 0.41. So this is the first negative answer, right? The first positive answer is going to be when I start from here and go into this angle. This is going to be this part, the first positive angle. The second positive answer is going to be this part over here. The third one is going to be skipping the first, the second, and going again over here. So it's all of this angle. And the fourth one is going to be skipping this, and coming back to it. This is the fourth answer over here. So the fourth angle looks like a full rotation. So that's 2 pi. So one full rotation is 2 pi. And then almost another full rotation. So almost 4 pi minus 0.41. So it's going to be 4 pi minus 0.41, which is going to be... Sorry, it's 4 rotations. Yes, here is the fatal mistake that we did. The thing is that we're looking for theta. Theta should be positive, not y. Okay, so if y is negative 0.41, we need to see how much is theta. So let's calculate theta. Theta is going to be negative 0.41 plus 3 pi over 8, and then everything divide 2. So theta here is 0.38 radians. So it's the positive answer. So this answer yielded the first positive answer for theta. So this is counted, this clockwise one was counted as the first positive answer. Okay, when we move this way, let's calculate the next y. So the next y is going to be pi plus this bit. So y is going to equal pi plus 0.41, so it's going to equal 3.55. So theta is going to equal 3.55 plus 3 pi over 8 over 2. So that's going to be 2.36. So that straight away gave me the next positive answer. How did I know that this one is the first positive answer? We can actually test. We can test going the other direction. So let's go clockwise. So let's go this direction, which is basically pi minus 0.41. So pi minus 0.41. Okay, so when y is equal to negative 2.73, because I moved clockwise, theta is going to equal negative 2.73 plus 3 pi over 8 over 2. So theta is going to become negative. So that's why just the answer after the negative 0.41 in y is going to start giving us this answer over here, which is the negative theta. That's why this was the confusion over here. I hope it's clear. So basically, what we are doing is that this first angle of y, okay, gave us a positive angle of theta, and we confirmed that it's this point over here. How did we confirm? Because we continued in the negative direction and we found out that our theta is decreasing now. So theta is negative. So if this is the 0.41, it has to be the first one, because the one after it in the negative y is going to give us a negative theta. Okay, so okay, so the one right after 0.41. So let's erase everything. So when y is negative 0.41, theta is 0.38. So in order to get a positive theta, I need to move this direction, because when I tried moving this y, it gave me a negative theta, right? So I'm going to move this direction. So when y is going to equal pi plus 0.41, that is 3.55. So theta, so this is this one over here. Okay, the third answer, which is all of this, is going to be this one. So the fourth answer, the one that I want, is going to be all of this. So 1, 2, and then back again. So it's basically one full rotation. Again, let me do it again for you so you can visualize. So it's going to be one full rotation plus pi plus 0.41. So it's going to be 2 pi plus 0.41. So 2 pi plus 0.41 is equal to 9.834. That is our y. So our theta is going to equal that y plus 3 pi over 8 over 2. So our theta is going to equal 5.51 degrees. So our value of theta at r is basically 5.51 degrees. So before you go, as I told you, I want to show you a quick preview. So this is basically the Math AS Mechanics Mastery. It's an alternative to tuition test. You don't need tuitions with this course. It's an alternative to tuition course. You don't need tuition for if you're gonna get this course. It basically has everything: introduction, kinematics, vectors, dynamics, moments, momentum, energy, everything, and then full past paper solved, and then summaries and keywords for you to go through. And it's basically me in the same exact whiteboard that I'm doing. It's me solving and explaining everything. It's honestly a gift Please check it out. If you want it, you can send me an email on abdurrahman.elminiawi@outlook.com. It's in the description. I'm going to send you a discount code. Other than that, please don't forget to like and subscribe. It helps a lot. Thank you so much for watching and have a nice day.